we got everything. A second. Not stuck. Yes. So next one, what is linear time invariant system? So we are going to see what is the condition for a linear time invariant system. So I'll see the system is given. So I have taken the different signals are given. We will take sync, triangular, rectangular, and triangular pulse. So we'll take sync and sync for both. What is meant by linear time invariant? We are going to understand that concept here. So I'm going to circularly shift the signal and plot, and I'm going to uh, see the outputs. So if I give x1, I give y1. If I give x2, I give y. I get y2. If I give x1 plus x2, will I get y1 plus y2? That is going to be the linear signal. And if I multiply by some constant and give, whether I'm going to get back my original signal. I'm going to see whether both are going to be same. This is how you verify this theoretically in signals and systems, right? Same thing is given to you for as a visual thing. So see here, the output. Here, this is your input, sync, sync. Both are same, right? So now you see individually what I am doing. I am adding a into x1, a1 into x1 plus a2 into x2. That is my third signal. This is the third signal. Now, last one, what I am doing, I am performing a1 into x1 first. I am performing a2 into x2 first. I am then giving it to my system and I am seeing my output. So I am adding totally here. Now I am adding it individually. So when you do that, you get the same signal, which means the system is linear time invariant signal. The system is linear time invariant system. I'll change the input sync and sync I gave. Sync and triangular pulse we'll see. You're getting the same thing. Yes. Now sync and rectangular pulse we'll see. It's also fine. Now sync and triangular pulse. Everything is same. Where is the twist? Let's see here. Amplitude scaling. We have assumed both to be 1. Assume this is 1 and I'll make it this as 10. Now will the answer be same? Will the answer be same? Yes. It's still the same. The amplitude is not going to make any change to my signal. Okay, so amplitude is not going to change anything. So scale x1 by 5 and x, see they have given try scale x1 by 5 and x2 by 10. Scale x1 by 5 and x2 by 10. That is done. And shift x1 1000 points to the right. The right 1000 points. Okay. And see here, x1 shift x2 500 points to the left. We cannot make 500, so I'll make it as minus 1000. Here I can make, I'll type it as minus 500. Define, now see, define and include a third signal x3 of your choice. You can even signal one more signal and you see that when you individually add the inputs, the output is same. When you add the inputs totally, the output is going to be again same. So this is the characteristic of LTI system. So linearity and time invariance both are coming into picture. And I told you again, all practical systems are linear, non-linear time variant system. Then why we are studying about LTI system? Just because we have a model for LTI system, we model all non-linear systems and time variant systems by linear time invariant model. Okay.